Okay, what we're going to look at with this next problem, and I've cleared up the slide again, is we've got the limit of x to the x power as x approaches 0 from the right. Now, if you look at this graph, it looks like there should be a limit because the graph has a shape something like this. Okay. And so if we look at the limit of this, guys, we get close to 0, like something's going on there. And so what we're going to do is we're going to do this whole natural log business again. And I've got the limit as x approaches 0 from the right of x to the x power, and I'm just going to rewrite it with this whole natural log guy in there. Okay, so now I'm going to look at the limit as x approaches 0 from the right of the natural log of x to the x power. When I do this, I can pull that exponent down in front of the natural log. So let's just deal with just the natural log part. So I've got x times the natural log of x. And again, we want to make sure that we can write this in a way that allows us to use L'Hopital's rule, but we don't have a fraction right now. And so the trick with that is to recognize that the natural log of x divided by 1 over x is equal to x times natural log of x. Just think about it for a minute. When you have a fraction and you're dividing, you multiply by its reciprocal. Okay, so now we can use L'Hopital's rule. So the limit as x approaches 0 from the right of the natural log of x over 1 over x. Now we look and see what's going on with that guy. And what happens is, as we get really close to 0 here, we end up with negative infinity on the top and positive infinity on the bottom. And because that happens, what we have to do is take the derivative of the top and the bottom. So if I let f of x be equal to the natural log of x, then f prime of x is 1 over x. If I let g of x equal x to the negative 1, which is the same thing as 1 over x, then g prime of x is negative x to the negative 2. Okay, another way to look at this one also would be negative 1 over x squared. Okay, those are the same things. So then I use L'Hopital's rule and I check again my limit. So no longer am I using this as my limit, but now I'm going to go, all right, I've got 1 over x divided by negative 1 over x squared. And multiply by the reciprocal here, the reciprocal of negative 1 over x squared. So this is 1 over x times negative x squared over 1. And the x's cancel in this case. And so you end up with the limit as x approaches 0 from the right of negative x, which is 0. So come back up here to this guy, right here. Okay, what are we doing? Well, we've got to now address the whole situation. Okay, we've taken the natural log, we found a limit. So now what we're going to do is we're going to look at the limit as x approaches 0 from the right of e to the natural log of my function, which in this case is 0. And that's going to be the limit, which is going to be 1. E to the 0 power is 1. So there you go. That's all there is to that guy. You know what? Let me rewrite this just a little bit to help us see it a little easier maybe. What if I said e to the natural log of f of x, which is what we just did, which is going to end up giving us e to the 0, which is 1. I know it's a little bit different, it's a little bit strange, but you know, we've worked a couple problems out like this. It's not too bad, so just hang in there, practice them, see if you can do the same exact problem on your own and get the same exact answer.